Hello Algebra 2. This video lesson is the second part of the discussion of the properties of exponents. And it all comes, as you know from the previous video, from chapter 6.1. We'll kick off where we left off. The next property is the quotient of powers property. Anytime you have two powers, one on top, one on bottom, both at the same base, you can, top and bottom of course being numerator and denominator, you can subtract the exponents, the upper exponent minus the lower exponent. More useful here, 5 minus 3 becomes 2, and 2 squared of course is 4. This really isn't finished here, calling it 2 squared. I am going to expect you, certainly in any case where the exponent, where the power is simply to the second power, I'm going to expect you to continue to the next step. And in some cases when it's to the third power, and maybe even beyond in a few cases. So here are some examples. 4 different versions. Hit the pause button. When you come back, I'll show you the right answers. Okay, here are the answers to those 4 questions. Notice, as I said, question 13, you have to take it all the way out to calling it 25. 5 squared is not an acceptable finished answer. Similarly, I'm not wanting negative exponents, so I'd like to see it written as 1 over 7 to the third. This is fine here, negative 2 to the 5th power at this point, though soon I will be expecting you to know 2 to a certain number of degrees, but we'll talk about that later in class. For now, that's a fine finished answer. But certainly this is not negative 3 to the negative 1. That ought to be 1 over, well, it would be negative 3 to the 1, but I also wouldn't consider that done. You're not going to expect to see anything listed as being raised to the first power. So this is really the final answer, 1 over negative 3. Next step. Sometimes there are multi-step operations like this one. I'll work this one out and then I'll give you a couple of similar ones. Remember, when you've got a power inside parens with another exponent outside, you can simply multiply those two exponents. 2 times 5 becomes 10. Now you've got 10 minus 8, or in other words 3 squared, but 3 squared is not a finished answer like we've said. I would expect you to write down 9 as the answer to that question. So now here are 2 others. Go ahead and carry those as far forward as you can. Hit the pause button until you have those, and when you do, I'll show you the right answer. Okay, I'm going to assume that you did that. For question 9, notice that you would have ended up with 5 to the 6th over 5 to the 6th, and 6 minus 6 after all is 0. This is for now an acceptable answer for another 2 minutes, really, or really 1. 5 to the 0 power. But let's talk about this one over here. Remember that 2, that exponent on the outside of the parens, gets distributed to both of the pieces inside, so it becomes 3 squared x squared. Well, 3 squared, of course, is 9. And now you've got 9 over 6, and x squared over x to the 5th, 2 minus 5 is negative 3. Well, remember, you're not supposed to leave a negative exponent, so it really is x to the 3rd on the bottom of the fraction. So it's 9 over 6, which simplifies down to 3 over 2. And this x to the negative 3 should be down at the bottom, so here it is, 3 over 2x cubed. This is the finished answer. And if you need to come in and talk with me about how to carry it this far forward and how to know when to stop, I'm happy to talk with you about that in class. But certainly this is the answer I'm looking for, and I'd be happy to discuss it if you think there's another answer that's appropriate. Now, I said I was going to come back to this idea of something to the 0 power. Well, there's another property called the 0 exponent property. Anything raised to the 0 power is 1, as long as the base itself is not 0 as well. So, for example, 3 to the 0 power is 1. X to the 0 power is 1. Whatever number is your favorite number, if it's raised to the 0 power, its value is 1. So let's look at this one. Negative 7 to the 0 power. Well, remember, exponents only apply to what they're next to. So that 7 becomes 1. So I've got negative 1. So the answer is negative 1 this time. The 0 did not apply to the negative sign, so it's negative 1. Based on these examples that I have there for you, Please work out these additional 3 questions, number 2, number 3, and number 4. Hit the pause button. When you come back, I'll show you the right answers. Okay, I'm going to assume that you hit pause to finish these and are ready to see those answers. This is going to be 2 over 1. And 2 over 1, after all, simplifies down to 2. So I'm not going to consider it a finished answer if you write it as 2 over 1. It really has to be finished off as 2. Everything in parens is influenced by that exponent. Or you could have said it's 4 to the 0 over 5 to the 0. It still amounts to the same thing. But what you're going to end up with here is 1. But this case, x to the 0 becomes 1. So I've got 1 times y to the negative 2. Well, after all, it's not supposed to be y to the negative 2. The y is on the wrong side of the dividing line, and it's 1 over y squared. And that's the finished answer to that last question. The next property is the power of a quotient property. If you've got an exponent outside parens, you can, if you prefer, distribute it to the 2 pieces inside. So it becomes a to the m over b to the m, or in this case, 2 cubed over 7 cubed. Now I will expect you to know that 2 cubed is 8. So this really isn't finished. This is what the textbook wrote. It's really 8 over 7 cubed. Let's look at some other examples. Here are 3 others. Carry these forward as far as you can. You ought to know, for example, what 3 cubed and 2 cubed are. But hit the pause button when you come back. I'll show you the right answers for all of these things. Okay, I'm going to assume that you did that. This first one here, like I said, you ought to know what 3 cubed and 2 cubed are, so this is not done. 3 cubed is 27, 2 cubed is 8. So your answer here is 27 over 8. But this next one becomes 3 squared over x squared, and you ought to know that that's 9 over x squared. There's nothing more you can do with that x squared, so this is a finished answer. The most complicated of the questions was this one. The fact that it's to the negative 2 power, or the negative second power, means both sides of the fraction are on the wrong sides of the dividing line, and a lot of people get this mixed up. In fact, in the previous video, I think I made the mistake of saying that you flip the question, and I don't want to confuse you. You're flipping this because both pieces inside are influenced by this exponent. If this exponent had only applied to the 3, then the 3 would move down to the bottom. But if the exponent hadn't been applying to the 4, then you would have left the 4 alone. In this case, it applies to both, so they both need to be flipped, and it ends up being 4 squared over 3 squared. Well, 4 squared, after all, is 16. 3 squared is 9. I'd suggest that you hit the pause button and look at this question for a minute and see if you understand the answer I've given you or have any questions. And if you do, please bring those into class. I'm going to assume that you've thought that one through and are fine with it or are ready with your questions for the next time I see you. Let's move on. There are a couple more ideas that I need to tell you about. One is scientific notation. The basic concept of scientific notation is you figure out how many spaces you had to move the decimal over so that you only had 1 digit in front of the decimal place. So in other words, you moved the decimal from, I'm trying to control my mouse here, from here to between the 1 and the 3, like it is shown here. In order to do that, you moved the decimal 8 spaces, and it becomes 1.314 times 10 to the, 8 for 8 spaces. Similarly here, I want one number or 1 digit in front of the decimal place, so I want it to become 2.5. I had to move it to the right 8 places. So it becomes to the negative 8th in this case, 2.5 to the negative 8th. Now let's look at this word problem. I'm going to show you how to solve this one, and I'm going to have you solve a similar one. There are 2 ways to do this. In the first way, I go right to the calculator. I set it up just the way they've written it, 265,280,000 over 3,780,000. And my calculator, and I'm going to have to round this because it's a long decimal, says it's roughly 70.17989. Well, that's not written in scientific notation, and they asked you to do it that way. Scientific notation says you've only got one digit in front of the decimal, so I moved it over one place. And it becomes 7.0 in the rest of the decimals times 10 to the first power. Because I moved it one space, it becomes to the first power. But there's another way that you can do this to get a quick, rough answer, and I find this very useful. You could have said this is roughly 2.6528 is roughly 3.0, and it's roughly 3.0 times 10 to the 8th. Similarly, 3.78 is roughly 4.0, and in this case 4.0 times 10 to the 6th. Well, remember, 8 minus 6 is 2, and so you've got 3/4 times 10 squared. 3/4 is 0.75. 0.75 times 10 squared, written in scientific notation, is 7.5 times 10 to the first power. Look how similar this quick, rough answer, and this is something that you probably can do in your head, but could quickly do with pencil and paper without a calculator. Look how similar that estimate came out to the answer that a calculator would have given you. Okay, so based on that, I'd like you to do a similar problem. Hit the pause button. When you come back, I'll show you the answer to this one. Okay, in this case, I'm going to first show you the answer for the rough estimate. I changed 2.26 times 10 to the 8th to roughly 2 times 10 to the 8th. And similarly, 2.1 times 10 to the 3rd, I rounded off to be 2 times 10 to the 3rd. Notice these 2's cancel now and become 1, and 8 minus 3 is 5. I've got 1 times 10 to the 5th. If you'd done this with a calculator, you would have found that 2.26 divided by 2.1 is 1.076, very close to the rough estimate I was able to do with pencil and paper without any need for a calculator. So I find that to be a useful quick estimate and a quick check to see whether or not I've punched my numbers in correctly when I did it on a calculator. Last challenge. See if you can decipher this problem. This is the kind of work that we're going to have in class next time we meet and for the homework the next time after this. Okay, I'm going to assume that you've hit the pause button and you've taken your best crack at this. I'm going to break this down into steps for you. My recommendation, if you get something as complicated as this, is to arrange numbers and variables in ways that make them easy to simplify. So I put the 5 over the 15, and I made a separate fraction. As long as I'm multiplying, I can do this with 2 over 8, because those are simplifiable. I put all the x's together, and I put all the y's together. Look what happens. 5 over 15 becomes 1/3. Negative 2 over 8 becomes negative 1/4. X squared, 2 minus 1 becomes 1. Negative 2 plus 3 becomes 1. And so I've got x over x, which is going to go away. And now here I've got y squared over y. Continuing on here, I've got negative 1 over 12. 3 times 4 is 12. And I get negative 1/12. The x's went away, and this simply became y to the first power. So this simplifies down to negative y over 12. This is how far I'm going to expect you in class next time we meet, and the homework after that, and then all exams in the future, to carry a question like this forward to get a finished simplified answer. That's it for this lesson. Don't hesitate to come in with questions about any of this. I'll look forward to seeing you next time.